Good morning, dear students, and welcome to this new topic. And I believe it is the most interesting and entertaining topic after each unit because this topic includes practical activities with simulation tools like Matlab. Okay, because these tools bridge the gap between the theoretical part and practical part. Okay, although in the first stage we just have some mathematical or models, mathematical models and mathematical representation, but really it is so important for the students to use tools like Matlab, okay, because these tools will link the theoretical results with and gain the students more confidence when the student compare the results of from Matlab with the theoretical results or the mathematical results by their hand. Okay. So without further ado, let's get started. In this session, we have a useful list of commands written by Professor, prepared by Professor Ridwan Al-Qasimi. He's from Saudi Arabia, but he is teaching in the South Florida University in United States. Okay, so here firstly we have basic commands and review for Matlab. We have to make a revision for Matlab. Okay, after that we have some spatial transformation, commands. Okay, after that we have more exercises with Matlab from the reference of introduction to robotics written by Craig. The author of this reference is Craig, which is one of the important references in the field. Okay, we have exercise, and this exercise contains a mixing between a tutorial or between mathematical problem and Matlab problem in order to compare both results to gain students more confidence about the topic. Okay. Also here we have Matlab exercise 2B. You can find these exercises at the end of each chapter of the reference of this reference. Okay. So let's start it by make a revision for the Matlab, how to use a Matlab, some of the fundamental commands used in Matlab. So here I make a combination, or I combine all of the review commands here. Okay, basic commands and how to use Matlab. Okay. First of all, here in Matlab, we have editor, for example. if you need to open this editor, just make new script. This window will open. Okay, yeah, you have to check your current working directory. You can change it at any time. Okay, you can change it at any time, because if you written any script means it's a program running inside Matlab script. Always the meaning of script is a program running or it is executed inside or above other application. Okay, for example, uh, here we have Mozilla Firefox. Okay, any code executed like JavaScript executed in this application, it is not executed in the server side. For example, we call it as a script. Okay, also in Linux, any bash, any code executed in the command line, not executed by compilers or interpreter, is called as a script. Okay, here we have this editor window. Here we have the current folder for the current directory. Here the workspace, any variable. Okay, because previously I make some codes. I executed some codes here. Okay, so firstly, if I want to clear this workspace from any variables, the workspace is like memory that contains any variable here. Okay, just right clear. Okay, if I want to clear this screen, for example, just CLC clear screen. Okay, as you remember, for example, I can make any execution here, any mathematical formula. 7 plus 4, okay. Answer equal 11. It is a variable, so it is stored here in workspace. If I want to assign a name to scalar, okay, just copy and paste and test it. Okay, here also you can just copy and paste this. It will be executed because n is stored here, for example. Okay, and so on. Also we have trigonometric functions here. Also we can define a matrix. We can define a matrix. This matrix, okay, has 1 row, 2 row, has 3 row and 3 columns. Okay. Each row is separated from each other by this semicolon, and the items of each row is separated by space or by comma. Okay. So I can make here comma, the same thing. Okay. Sorry for that. We have to unify. We have to the same thing. Just because here on I think it is written as L. Okay. So it is the same. Also, I can define a vector. Yeah, this vector has 1 column and 3 rows. It is different from 1 by 3 matrix. It is Usually we use this vector because vector represents points. It is written like this. Also, I can write a vector by putting transpose here at the end. You'll see the transpose like here. The transpose, okay. Transpose, you can write transpose like here or just add this value. Okay. You can make a cross product, dot product, yeah, dot product between two matrix and vector. Here we have 3 by 3 multiplied by 3 by 1. 3 by 3 multiplied by 3 by 1. The result is 3 by 1 matrix or vector. Also here the cross product. The dots product, the cross product. Okay. Yeah, the cross product between two. The cross product between two vectors, between B and C. We also have a transpose. Okay, the transpose you can check it. Or you also have a transpose determinant. The determinant of any matrix. Here the inverse. This code for the inverse and so on. You can check all of these. Here also we can put we can define symbolic characters. Okay, instead of using numbers inside matrix, we can use these characters. We can make the answer look prettier or nice shape with pretty. We can simplify. For example, if I have sine square plus cosine square, it will be simplified to equal 1. Any mathematical simplification. And also loop statement. You can just copy and paste. Okay. For I equal initial value step, and then the limit or the final value. You can test all of these codes. Please check if there is any timing error. Okay. Also for the function, in order to make a function in M file, we have to write the name at the start of the file function and end, or write the name of the function. This function, the input for this function is xy. It will implement this formula, z equal 2x plus 3y. The output is z, but it will return x, y, and z. Okay, you can open any file. Okay, paste, save it. Okay, for example here, that's the same code. You can copy it. Save this code. Okay, and save it in any Control S. And for that, okay, it will take the name of the function. You can save it here or in any place. Okay, you can save it here. It is also this location. Okay, or you can save it, for example, in documents. Example, save it. But in order to execute it, we have to change the parent folder with this folder. Okay, so just want to change this folder here to use this current folder. After that, just I will call this function in the command line like this. Okay, so the input is 21 and 30 and the output is ZYX according to the formula. So you can check all of these. Okay, also we have a plotting command. Okay, for example here we can define time, for example. To take, for example, 0, 1, 2, 3, 4, 5, 6 till 5. Okay, this line Q1 we can also matrix 6 element, any 6 element, 3, 1, 2, 3, 4, 5, 6. Okay, also Q2. One, two, three, 4, 5, 6. Also we can change example. Value here. And Q3, for example, change some numbers. Sorry, Q2, Q3. Okay, after that you can use this function, okay, to plot. For example, I can first open any figure. Okay, clear figure, and on that figure I can draw these 3 lines. Okay, here we have these 3 lines, and you can compare your code. First line is red, is dash, is a solid line, and the second is green dotted line. Okay, and the last one is dashed line, and there is, for example, plus mark for each point. Here we have here dotted, and it has a dot mark. Okay, the line width is 3 here. Options. So you can test all of this. Please copy and paste and check for this grid on. It will maintain this window. It will make a grid inside. Okay, here we don't have a grid here. It will make a grid. Okay, a net of points. Like this. You can also title. You can put title here, X label, Y label, ligand. Okay, for example. ligand to the figure for each variable and so on. Okay, you can try all of these commands in your home. Okay. Okay, so also you can plot in 3D and so on. Okay, please, you can try all of these commands. Now we want to move to the how to use a Matlab robotics toolbox. Okay. Also, I have written these commands from the the materials of Professor Ridwan Al-Qasimi, okay, in order to test some commands, but you can use the demonstration part of this robotics toolbox directly. RTB robotics toolbox RTB demo. Okay, if you write this RTB demo after installing, in order to install it, as explained in the course description. In the course description, just download the Matlab robotics toolbox. Then please, from the website of the author of this toolbox, who is Peter Cork, then double click on it in order to install it. Okay, or just open the directory. Okay, open the directory of the for the downloaded for the download folder, and choose this toolbox. Okay, yeah, you can check the existence of this Matlab robotics toolbox in the add-on manager. The add-on manager, you can find here. These are all the toolboxes for the math works, the math works. Okay, here we have a Matlab robotics toolbox for Matlab. The author is Professor Peter Cork. Okay. Okay, just in order to investigate anything inside this Matlab robotics toolbox, just write RTB demo. Currently, we are in the course of spatial transformation, so you just need to hit this button for the and choose these options for rotations and transformations. If I choose rotation, okay, it will make a demonstration. Run this script. Rotation of pi over 2. If I write this command r equal x, rotation around x axis with pi over 2 angle, give it's okay, it's clear, which we can see is a 3 by 3 matrix. Yes, continue. The determinant of R equal 1. The determinant of such matrix is always 1. Continue. This just you can also write this command after ending of this script to check. Continue. Okay. Let's create more complex rotation. Here we have this rotation. degree is option because the default value, the argument for this function is in radian. Okay. If I want to enter the angle in degree, I have to write here rotation here. This function is used as compound to represent the compound transformation, just rotation of matrix, dot product of matrices, rotation around x. So here we can represent it as post multiplication of sequence of post multiplication, rotation around the current axis r30, then rotation around y 50 degree, then rotation around z. Or I can represent this as a rotation around fixed axis with pre-multiplication. Firstly, I will rotate around the fixed z-axis with 10 degree, then a rotation around y-axis with 50 degree, then 30 degree. Here we will obtain the result. Continue. Where this time we have specific the rotation angle in degrees. Continue, continue. Okay. Any rotation can be expressed in terms of single rotation above some axis in space. Okay. For the above rotation matrix. Okay. As we said before, any rotation matrix can be represented as a rotation around axis, unit vector in space by amount of theta, and this function will return the theta and this vector, unit vector. Okay, and the output is irradian. The theta is the angle in radians. Continue. And vector is a unit vector representing the direction of the rotation axis. Continue, just continue. Okay. Commonly, rotations are represented by Euler angles. Here you have, we want to translate from TR to Euler. Okay, from transformation matrix or rotation matrix to Euler. Okay, it is the angles, three angles in radian, such that are equal rotation. Okay, this function is used to a special case of Euler angle, the rotation around z. Okay, z, the rotation around y, the rotation around z. Rotation require about the z, then y, then the x-axis. Continue. Continue. Okay. Also, we have transformation from rotation to RBY. Okay. RBY, also given by roll, pitch, yaw angles. Okay. Rotation around x, y, and z, which are three angles such that r equal r rotation x, y, z. The rotation require about x. Okay. This rotation can be expressed in two terms. Okay, it can be represented as a rotation around current axes, like Euler angles, x, then y, then z, post multiplication, or the default value is rotation around z, then y, fixed axis, then x. Okay. Continue. Okay. Also here we can investigate the effects of rotations about different axes using this graphical user interface based demonstration. The menu buttons allow the rotation axis to be varied. Okay, example here, rotation around Z, fixed axis, fixed axis about Z, it's the Z axis, rotation about Y, this here Y axis. Okay, the rotation around Z, around X, around the fixed axis. Okay, at the 0, at the 0. Okay, if I want to this, that be Y. If I want to check the Euler angles, R, Y, Z. Okay, it will be changed here like this, around Y, around Y, but the rotation around Z will be based on the current axis around Z. Okay, about new Z. Okay, because this will be new Z. The red line or the red points at the end of this circle represents the new vector of Z. Okay, so here the rotation around this new vector. Okay, also if I want to rotate around Y, yeah, here I have new Y, around new Y, and so on. You can check all of these functions at your home. Okay, continue. I think here we go. Here we end this nice tutorial. Okay, also we can check the transformation. Okay, translation, this function, just make translation. Here we will see the rotation matrix is equal 1 1 1. Just add translation to the homogeneous transformation matrix. Okay, pi over 2 equal 90 degree. This will return, instead of rot y returns rotation matrix, but the T ROTY will return the homogeneous transformation matrix rotation around around Y by pi over 2. Continue. Also rotation around Z, homogeneous transformation is just rotation around Z by minus pi over 2. Continue. Also here also we can make concatenated by multiplication. This may be concatenated by multiplication, translation, the rotation around Y, the rotation around Z, the translation, and here the compound effect of rotation around Y, then rotation around Z. Continue. With this transformation, for example, here we have this transformation T. If I multiply this transformation, homogeneous transformation matrix, with this vector, with this represented the origin of new coordinate frame with respect to the world frame origin 0 0, that new origin will be given by this vector represent the origin. Okay, x, y, z, 0, 0, 0, and 1 is used as a temporary number for homogeneous transformation. So I have here the 0, 0 in the new frame represented by this homogeneous. I want to find this point with respect to the world frame, the world frame. Okay. Continue. Also here we just from transformation matrix you can find the Euler angles. ZYZ or ZYZ, or also in roll pitch yaw like before, radians. If I want to convert this from radians to degree, I have to multiply it by 180 over pi. Continue. Here also we have a compound transformation matrices. The first one contains just the rotation around x, and the other contains rotation. TR means it's transformation, homogeneous transformation matrix, just by multiplication. Here, just we finish this journey, this interesting journey. Okay, and you can test the same. You can use the same to test Prof. Ridwan Al-Qasimi, this sample code. Okay, but remember here you have to enter a unit vector. Okay, unit vector. You can enter any vector with any amplitude. The software will convert it in the unit vector, but when you make this inverse expression, it will return this function will return the unit vector. Okay, the unit vector. So please don't confuse if you find a different result when if you make the inverse function. Okay, don't be confused. Okay. Also, in order you can end any command by just click Control C. Okay, Control C. With Control C, you can terminate any script. Okay, we can also find information about any function here. For example, Euler to transformation. For example, help. Just type this function, any function. The Matlab will return the stored help or the documentation about this function. Everything you have to know about this function will be returned by the Matlab. Okay. So please use this function for each this command for each function in order to know exactly the type of inputs accepted by this function. Okay, the type of options. Okay, and the output of this function, 4x4 transformation matrix, 4x4 matrix. Okay. Okay, let's go ahead to the exercise, Matlab exercise. This interesting Matlab exercise. Okay. example, in this Matlab using the Z, Y, X. Please pay attention to this sequence. Z, Y, X, Euler angle convention. Okay, it is equivalent to the roll pitch yaw. Okay, write a Matlab program to calculate the rotation matrix RAB when the user enters the Euler angles alpha, beta, gamma, alpha, beta, and gamma. Okay, alpha, beta, gamma, and also alpha with 30 beta, gamma. Okay, in this exercise, please be attention. The rotation around alpha means the rotation by alpha means the rotation around z-axis, and the rotation around gamma means around x-axis. Okay, so we can enter any combination of this. Demonstrate the 6 constraints. I demonstrate the beautiful property, the inverse equal transpose. After that, write a Matlab program to calculate Euler angles, the inverse case, when the user enters the rotation matrix. If the rotation matrix is used as input, okay, calculate by your hand both possible solutions. Demonstrate these inverse solutions for 2 cases from part B. Okay, just to check. For a simple rotation of beta about y-axis, here we have a rotation matrix around, and we have a vector B. Calculate PA, the new vector after rotation around y-axis. Demonstrate with the sketch that your results are correct. So we have to check all results by means of Cork Matlab Robotics toolbox. Okay. So here we have some solutions by hand, alpha, beta, gamma, and this is the result. And this is the result of this computation matrix. Check the relationship, column-wide orthogonal demonstration, and the unitary relationship, and also demonstrate the beautiful property. Okay, here we have another angle. Okay, I have here some example of code. Okay, provided by Dr. Bob Williams from Ohio University. For this case, so we will use this new function. Okay, by the way, if I want, for here we have script, and we will run this script from the editor here. If I want the output result for any command line to be shown or to be displayed in this command window, just I have to remove this semicolon. Okay, for example, if I remove it, it will be shown here. Okay, so I have to enter, because here angles 1 means the first value of vector, so I have to enter these angles in the form of row, 1 row, as a matrix of 1 row and 3 columns. Then we will use, in this example, we will use mostly all almost all the commands used for rotation. Okay, tz equal trotz alpha, troty beta, trotx gamma, rz equal tz tytx. Okay, this command will provide will give us rotation matrix homogeneous. If I want to find the rotation matrix from here, I can use this command to extract just the first 3 by 3 matrix, or just use ROTZ command. Okay, after that I will make multiplication. We will see here, because here we have rotation, Euler angles, okay, z, then y, then x, Euler angles. Although we'll use the raw pitch function, but here we rotate around the current axis, z, y, x. Also, we can use rotation matrix. Matrix is multiplication or homogeneous transformation, compound multiplication. We will compare this traditional way with the with this other function, with this function of raw pitch yaw conversion to transformation matrix RBY. Pay attention here, the default output here, this roll gamma, roll pitch yaw x, y, z, but the default output of this, it will be the rotation. The default value will be z, y, x as Euler angles, or x, y, z as fixed angles. Okay, pay attention to that, r, y, z as a rotation around current axis in each sequence or in each stage, or on other hand it also represents x, y, z. I made a correction here because in the original code the gamma is exchanged or replaced by alpha. Okay, so you have to check your code and the results of this command have to equal the output of this command. Okay, then I can extract just the rotation. I can verify by cross product the first column, 1 to 3 column for the 1 to 3 rows for the first column, and the second column. This cross product will equal the third one, or I can just make also a dot product. Okay, a dot product for this example also. You can do this to check it, dot product. But here I have to convert this to transpose, and then we'll find norm B. Okay, this is a part A. Okay, in order to run this code, okay, just I have to also pay attention here. The angles will be entered as a degree, and this expression will convert it to a radius, because all the functions here accept just the radians. But if I make here options degree, it also can accept a degree for some functions. Okay, so just I have here to run the selection. alpha, beta, gamma. So I have to enter it in a matrix format: 10, 20, 30. Okay. So you have to check all the output. Any line, for each line that does not contain the semicolon, the output will be displayed here. Alpha, also TZ. Okay. Transformation matrix, RZ, 3x3 rotation matrix. Extract it from this transformation matrix. Then R multiply and T multiply, the R multiply, and if I compare it, if we compare this, if we compare the output, you can find that they are identical to each other. Okay, after that I will use this function, okay, after this correction, conversion from roll pitch yaw to transformation basic gamma beta alpha. Okay, we will obtain this result, and this result, as you can see, is identical to this result. So everything is okay. Okay, I can extract the rotation matrix. Then I can make cross product for the cross product of the first column with the second column will give us the third column. Okay, and so on. Yeah, this so this cross product equal the third one. Yeah. Okay. The norm is equal to 1 here. There is here some error. We have to exchange this with each other, because here we have 1, 2, 3, 3, 1, 3, 1, 3 rows and 1 column. Here 1 rows and 3 columns. Those the output is 3 by 3. But if I convert these terms, the output will be 0. Okay, and the norm is equal 1. Okay, the norm is equal 1. Okay, for part B, we have to check the angles. We convert the previous transformation matrix to the corresponding angles, inverse solution. Okay, the angles in radians, I have to multiply these angles or divide by the conversion term. Was the angle 30, 20, 10. And if I also translate the direct multiplication of homogeneous transformation to the corresponding angles, also the angles will be 30, 20, and 10. Okay. Finally, the final example here, we have to make a rotation for a vector around the y-axis by I think about by 20 degree, in degree 20 degree. Then I have to enter so then I have to enter 101, this row, rotation around y by 20 degree. I have to obtain this one. When we multiply this rotation matrix with this vector, we will obtain the new vector 1.2 0.59 matrix. Okay, we can check this result 1 0 1, and then transpose to convert it into a vector. Okay, because here I make a semicolon just to the output is not displayed, but I can write PA here. Okay, because it is here P capital, it is sensitive to capital and small. Okay, so everything is great, is okay. Also, I can make a correction. You can check also this this formula also. Just make here transpose here. Okay. Also, so the answer is 0 because E exponential of minus 17 is 0 because we have some rounding in Matlab. Okay, in the multiplication, every multiplication has some approximation. Okay, so this answer is equal to 0. Okay, everything is great, everything is okay. We make here a great achievement for this example. Okay, so you can check all of these. Okay, I want you at your home to implement this exercise as a homework. Okay, and compare your result with these mathematical results. Okay, and the okay, please check all these results. And thank you very much for your attention and your time. In the next lecture, we will go forward to the next module of forward kinematics. Thank you very much.